Good afternoon, gentlemen. I just wanted to reiterate the refrigeration cycle for you guys so that you don't forget. You should be drawing it every day. Just remember that the metering device, in this case the TXV valve here, is both on the high side and the low side because it's taking the high pressure liquid and turning it into a low pressure liquid droplet surrounded by vapor, all right, going into the evaporator. All right, the evaporator now is going to absorb the heat from inside the structure, all right, which is going to raise the temperature and boil off those droplets, turn it all to vapor. Then you will have 55-degree air supply going out into the structure's room air, all right, and then you should have, because this is a TXV valve with a sensing bulb that maintains constant superheat, all right, you should have a 10-degree superheat from the metering device to as the line comes out of the evaporator going back to the compressor. So now we've absorbed heat. As we go back, we have our service valve. We check our superheat here if we don't have a TXV valve. All right, the temperature is slightly going to rise as it returns back to the compressor. The compressor here holds all vapor, should have no liquid refrigerant in it whatsoever. It will do damage to that compressor. It's going to compress it, all right, into a high temperature, high pressure, superheated gas that is now going to go out the discharge line and go to the condenser. The condenser, the temperature going to the condenser is going to be hotter than the outside air, so that the outside air that goes over the top of that gas now will cool it off and turn it back to a liquid. So it'll be all liquid as it comes out of that condenser. The heat that was inside the structure is now going to be expelled back outside. All right, so now we go to our liquid line. We have a service valve there where we hook up our manifold for our high pressure side. We take our subcooling reading on the liquid line with a temperature gauge. All right, so the saturation temperature is 110 degrees. So if I had a line temperature of 100 degrees, I would have a 10-degree subcool. I have a filter dryer to filter out any moisture or non-condensables that might be in the system. And then I have a sight glass. All right, the sight glass will tell me after startup if the system is fully charged or if it has it needs more refrigerant because it has air bubbles in it. All right. So after a few seconds, when it starts up, it will have some air bubbles in it, and then they should go away, which tells me that the system is charged correctly. All right, so thank you for joining us today, and hopefully everybody is doing well, and we'll talk to you later.